Chapter 3-2. Increased Training Datasets, Part 1. In this experimental study, I aim to explore two key aspects. 1. How increasing training samples influences the number of samples, surpassing the 95% confidence threshold. 2. How increasing training samples impacts the prediction accuracy of the collected samples. As illustrated in this figure, Model A is trained with a subset of the training dataset to learn the 8 grandparent-level labels using neural networks, while Model B utilizes the entire training dataset. Following the completion of training, Models A and B are evaluated for the following two criteria. 1. Determine which model collects a greater number of samples exceeding the 95% confidence threshold. 2. Evaluate which model achieves higher accuracy for the selected samples. Chapter 3-2. Test Conditions. For this evaluation, I utilize models A and B, as described in this figure and the table. Model A, trained with subsets of 3 datasets, focusing on grandparent-level labels. Model B, trained with the complete datasets. Chapter 3-2. Best Test Case. Model B1 stands out as the top-performing case, trained with all samples from training dataset 1. 2 reasons support the selection of Model B1 as the best. 1. Model B1 identified the highest proportion of samples with a confidence exceeding 95%. 2. Although its accuracy is slightly lower than Model A1's highest accuracy, the significant difference lies in the proportion of samples selected. 82.8% for B1 compared to 73.7% for A1. Chapter 3-2. Testing Dataset 1, Test Result. In summary, Model B, trained with the entire dataset, outperforms Model A, trained with a subset. As depicted in this figure, Model B selectively collects a larger portion of samples, 84%, compared to Model A, 75%. In terms of prediction accuracy for the selected samples, Model B achieves 91.3%, which is slightly lower than Model A's accuracy of 89.9%, 1.4 percentage point improvement. Chapter 3-2. Testing Dataset 2, Test Result. Model B shows better performance than Model A, as observed in 2 figures. Model B selectively collects a larger portion of samples, 82.2%, from testing dataset 2 compared to Model A, 74.6, or 70%. The prediction accuracy for the selected samples shows minimal difference between Model A, 88.5%, and Model B, 89%. Or Model A, 89.7%, and Model B, 86.6%. Chapter 3-2. Conclusions. 1. More training samples mean a broader range of confidence evaluation, potentially increasing the number of samples surpassing 95% confidence. 2. Just adding more training samples doesn't guarantee improved accuracy for samples with 95% or higher confidence. Both sample quantity and quality matter for accuracy. Therefore, in the next phase of my AI recognition design, it is crucial to research how to enhance recognition accuracy by improving sample quality when the quantity of training samples increases. Thank you.